Alrighty guys, so let's move on to question number 5. Basically 5 is just kind of a carryover from 4, where this time, rather than comparing our sociology majors to the whole population, we're comparing sociology majors to marketing majors. So see how this is a different type of question. In those first two, so questions 3 and questions 4 that I went over before, those were both comparing a sample statistic to a population parameter, right? We had a sample mean, and we compared it to a population parameter, the population mean in that case. And whether we use a Z or T just depends on if we know the population standard deviation or not. Again, I just went over that. This question's a little bit different because we're not comparing a population to a sample, we're comparing two samples to each other. So we're comparing two groups. So again, if you go back to my original lecture videos, this is the third of the 4 types of hypothesis testing. The fourth one I felt like was a little difficult, so I made that the extra credit question. I'm not going to go over that, but hopefully some of you guys will be able to answer that one. But even if it's worth a crack, give it a shot. But these questions really do go in order of the lecture videos. So make sure you're clear on that stuff. But let's go over this question. Okay, so the same researcher, we've got the same sample of 65 folks in sociology with their high school GPA of 3.48 and a deviation of 0.11. Then the researcher took this sample of 85 marketing majors, found their GPA was 3.55 and a standard deviation of 0.21. So we want to test for the differences. So again, the first thing you want to do, I do want you to write the assumptions. There's several assumptions that in order to do hypothesis testing, hint, hint, one might be that the samples are sampled randomly, but those are directly in the PowerPoints. I just need you to know what the assumptions are in order for us to do statistical testing. Because if I don't give you a random sample, you can't do any of this. So just make sure you're clear on those. The second part is to fill out that table again. Again, I'm giving you as much as I can here, trying to make it straightforward as possible, but just fill in the variables. So we've got a sample size for sociology majors, their the mean GPA, the standard deviation, and then we can calculate their degrees of freedom, and then the same with the marketing majors. So let's fill out our table. So how many social majors do we have? Well, we had a sample of 65. Our mean was 3.48. And we had a sample standard deviation of 0.11. Sorry. It's hard to hold this thing and write at the same time. It's definitely kind of a challenge. All right, degrees of freedom is really easy. Remember, degrees of freedom is just n minus 1. N minus 1. Okay? So it's 65 minus 1, well, it's 64. Simple. Okay? We had 85 marketing students, a mean GPA of 3.55. The standard deviation for marketing students was 0.21, and the degrees of freedom, 85 minus 1 is 84. Okay, so that's these are all the variables you need. All this information here is all you need to fill out, to do the equations and answer the question. Again, make sure you're writing this stuff down. You can't just put this in your calculator. You can't figure it out in your head. You got to write it down. So the next thing you got to do, as always, research and null hypothesis. And when you're comparing two groups, the research and null hypothesis are actually a little bit more straightforward than when you're comparing a sample mean to a population mean as in the questions before. Here are H sub 0, our null hypothesis, is just that the mu for marketing students is equal to the mu for sociology students, right? So that the means are equal. So, we can see that it's like, oh, marketing is a little bit higher, but the question is, can it be driven by chance? Could that be randomness? Is it driven by sampling error? Or are these means truly different than one another? Remember, same thing. Go back to the central limit theorem. We're really estimating a point and then a confidence interval. Think back to your estimation stuff, questions 1 and 2. All this stuff connects. Okay. So the null hypothesis is easy. It's just that the two group means are equal to each other. So the overall mean for marketing students is equal to the overall mean of sociology students. Basically, that their GPAs are not different. And then the the research hypothesis, again, I will dictate whether I want a one or two-tailed test. I'll always tell you, but you know, we really only use a one-tailed test if we have theory to back us up. In this case, we don't really have any reason to believe that marketing students have different GPAs than Soc students. We just want to test that they're not equal. So mu for marketing is not equal to the mu for sociology. Easy, okay? Here's our null hypothesis that we assume is true until we can prove otherwise. We're going to calculate a test statistic, and we're going to compare it to the critical value, and that's going to make the determination for us. Now, the trickiest part on these types of questions are the equations. Like I said, you're going to have to write this stuff down. You just simply can't put this into your calculator right away. It won't work. So the equation that we want to calculate, well, let's go back here. I think I put it here, and I did. I told you a t-distribution. When you compare two group means, you always use a t-distribution. I didn't have to tell you that for you to, technically I didn't have to put that there. That's just a little, just to kind of help you out. But we're using the t-distribution, just so you know. So in order to calculate our t-statistic for the difference in group means, we have to use this equation here, okay? So let's write that down. T is equal to, I'm going to need paper. Let's flip up here. T is equal to x bar of marketing minus x bar, or let's make it for, it really doesn't matter, just as long as you're keeping your groups separate. Whatever you define as group one, you make sure it's group one from there on out. So let's say, I did before that Soc was group one, so let's say the x bar for group one, sociology, minus the x bar for marketing, divided by the standard error of the differences. So this goes back to the sampling distribution of the differences and the central limit theorem. That I'm going to upload some videos to help you out on that. That's going to be something that you're going to have to, pick apart the understanding on your own. And if it's not clicking, you're just going to have to buy that it works, because it does. But here are your, here's your equation that you use here. So it's basically the sample mean of group one minus the sample mean of group two. And that's easy. We already had that. Right, we've already got the sample means for Soc and marketing. So I can go ahead and put that in here. So its sociology mean was 3.48 minus 3.55, okay? But the problem is you got this standard error of the differences. So remember back to the estimation stuff, you had to calculate the standard error. Now we're not interested in just the standard error for one distribution of means. We're interested in the standard error of the difference between two means. Okay? So here's your equation for that. It's this lengthy, dense-looking one. However, if you look at it, all it is sample means. All it is sample sizes, right? The n's. And then two places you put the standard deviation. This is the sample standard. It's really easy. There's actually, in terms of plugging the numbers in, it's not difficult at all. This is the point where we'll see how organized you are and if people are writing things down. Let's get this down on paper. So the standard error of the differences in the group means is equal to the square root of n Soc minus 1 times the standard deviation for Soc squared, plus n for marketing minus 1. And if you look at these, n minus 1, that's the degrees of freedom. That's all that is. And marketing minus 1 times the standard deviation for marketing squared, all divided by n of Soc plus n of marketing minus 2. Again, there's your degrees of freedom for the whole group because you add the two samples and you subtract 2 instead of 1. Don't forget the last part, which is the square root of n for Soc. You see how I'm already running out of paper here? Let's continue over on here. So we've got, so make sure you're seeing this, n Soc minus 1 times the standard deviation of Soc squared, plus n marketing minus 1 times the standard deviation of marketing squared, divided by n marketing plus n Soc minus 2, multiplied by So you multiply this whole thing by the n of Soch plus the n of marketing divided by the n of Soch times the n of marketing. And you take the square root. Okay, so you can see right away how it's a complex equation, but there's really not much here as far as like what numbers do you plug in. So I'm gonna plug the stuff in just so you can at least have the formula set up to go. So the standard error of the differences is going to be equal to the square root, what's n Soch? Well, that was 65 minus 1, times the standard deviation of Soch, that's 0.11 squared, plus the n of marketing, 80, was it 85 or 86? 85. 85 minus 1 times the standard deviation for marketing, 0.2, was it 22 or 21? 21. 21 squared. You see how I just, plug that stuff in. Easy. Divided by the n of Soch, 65, plus 85, n of marketing, minus 2. All multiplied by the square root of n Soch plus n marketing, 65 plus 85, divided by 65 times 85. Okay? So, I'll let you start with that. What does this all come out to? It gives us the standard error of the differences. We'll get a number here, and then if you look here, that's how you calculate the t. So your answer will go up here. Okay? And you'll take 3.48 minus 3.55, which will be negative 0.07, and divide by whatever the standard error of difference is. That will give you your t statistic, right? Because t is equal to the difference in the sample means divided by the standard error of the differences. We calculated this whole big thing, standard error of the differences, plugged it in here, divide, you get your t statistic, and that's our test statistic. Now, same as before, in order for you to test to see whether your null or research is, your conclusion, we assume the null until we can go with the research, just like we assume innocence until we can prove you guilty. In order to do that, right, we calculate that test statistic, and then we compare it to a critical value. So here's the critical value. If the test statistic is below it, then we go with the null. If the test statistic is above it, then we go with the research. Okay? So let me help you out with finding the critical value. I'm looking for a 95% confidence level, so 0.05. Remember, I was using a two-tailed test and a t-distribution. So let's go to the book, find our t, two-tailed test, 0.05, right? Now again, the t-test is always based on the degrees of freedom. So it was easy when you had one sample and your degrees of freedom was just n minus 1. Well, degrees of freedom for two groups is just as easy. It's just group 1 plus group 2 minus 2, right? So, kind of before, when we calculated that the degrees of freedom for marketing was 84 and degrees of freedom for Soch was 64, because we just did, n minus 1. You could just add these two together because this is, n1 minus 1 and n2 minus 1, so n1 plus n2 minus 2. I mean, you get the same thing. It's 65 plus 85 minus 2, right? That's going to be your degrees of freedom for the whole group, for both groups. Okay, so you're going to get 148. You get the same thing if you add these two together. 64, 84, you're going to get 148. So you go to the back of the book. Degrees of freedom 148. It only goes up to 120, otherwise you use infinity. We want to find a two-tailed test at the 0.05 level. 1.96. So your critical value is 1.96. 0. If you want to include that, I don't care. If your test statistic that you calculated is below 1.96. So let's say it's 1.2. Then we fail to reject the null, aka we accept the null. If we fail to reject it, it's like we couldn't find enough evidence to say it's not true. So in that case, the marketing and social students have the same GPA. If we find a test statistic that's above the critical value, then we're going to reject the null and accept the research. And we'll say that the marketing majors and sociology majors they are different. There are differences in their GPA. But the key is calculate the test statistic and compare it to the critical value. That will determine your decision. So here's your computation. That's going to be part D. And then your decision is going to come down to whether you reject or fail to reject. So your critical value that you'll use in the question, you can go ahead and write it down. It's 1.96. So if the test statistic you calculate, if it's less than 1.96, then you fail to reject the null, meaning you accept it and you say that they're not different. Now, if let's say you get a test statistic and it's greater than the critical value, then you would reject the null and accept the research hypothesis. And you would say, well, we're 95% confident that there is a true difference in the average GPA for Soc and marketing majors at VSU. Okay, so hopefully that helps out. There was a request about question 6. There's no other way I can explain that. I'm gonna upload a couple YouTube videos for you to see other people explaining it. You gotta look in the book on that one. That's gonna be your understanding. The other thing, like I said, is the central limit theorem is difficult to, it's gonna be tough for some of you. If it's something that, if it's not clicking, if it's just not making sense, you're just gonna have to kind of buy it. Like I said, in order to answer this, I only made this question 10 points because I know it's going to be tricky for some of you, but please use the book, use the notes. I don't care if you're, just kind of rehashing things directly from the book. Just, you have to sort out in your mind what the central limit theorem is and how we know that a sample statistic is somehow representative of the population parameter based on the, a hypothetical infinite number of samples with the sampling distribution of the means. Go back and read the book on that one. And then I do have an extra credit question, which is a little bit tougher, but take a crack at it. I think, it's worth at least giving it a shot. But if you'll note, the extra credit question is worth 10 points, which would cover for, the only question where you're going to have to, it's the only question in the whole class you'll ever have to write an essay for, but I want you to write an essay on the central limit theorem. So that's all I got. Do your best and, just take your best shot at this, do your best and just get these in, just turn the exam in. Trust me, you don't want to be spending hours and hours and hours on this. Just take your best shot. If you have any specific questions, you can email me. But otherwise, just get this stuff in. Keep in mind that I'm probably gonna have to curve the tests again. I think some of y'all tend to underestimate yourselves anyway. So just do your best and get it in, and we'll kind of move on from there. So that's all I got.